I've created three simple groups to demonstrate the calculation of the F statistic. First group has 5 values, second group has 5 values, and the last group has 5 values. You can use the analysis of variance to determine whether the populations that these samples were taken from have the same mean or different means. Let's consider what we're trying to prove with this analysis. First, our null hypothesis is that the means of the populations that each of these samples is drawn from are equal. Our alternative is that at least two of the populations have different means. Let's also consider what our assumptions are. First, our distributions should be normal. Secondly, we're assuming that our distributions are independent of one another. And finally, that they have equal variances. Let's consider what the value of our F statistic is. F is equal to the variability between the means divided by the variability within the groups. In the past, we've calculated the variance by adding up the sum of the squares of the differences between each individual value and the mean, and dividing by the sample size minus 1. We're going to do a similar calculation for the means of each of the groups and for the values within each one of the groups. The value of the F statistic is going to be the ratio of those two values. Let's begin by finding the value of the mean for each of the three groups. Now I'll copy the mean into the column next to the values. I'm changing the notation to absolute addressing so that I can fill these values down. Now I'll calculate the difference between each value and the mean for that group. Our next step is to square the differences between the values and the means. For each group, we'll calculate the sum of the squares of the differences. These values represent the sum of the squares of the differences for each of the groups. I'm going to add them together to give me the total sum of squares. The number of degrees of freedom are represented by the number of samples within each group minus 1. So we have 5 minus 1 is 4, plus 4, plus 4. The degrees of freedom are going to be equal to 12. The mean sum of squares is the sum of squares within divided by the degrees of freedom, or 25.2 divided by 12. So our value comes out to be 2.1. Let's organize the values for the means of each group over in another part of our spreadsheet so that we can work with it. Now let's calculate an overall mean for all of the values in all of the groups. I'll copy this overall mean down into the next two cells. Now calculate the difference between our overall mean and each of the individual means. Now I'll calculate the squares of the differences between the means. In this case, we were fortunate all of our groups had the same number of values. That's not always going to be the case. I'll accommodate that by multiplying the number of values in each group by the square of the differences for that group. Now I'll find the total sum of squares. In this case, the degrees of freedom is equal to the number of groups minus 1. I'll divide the total sum of squares by the number of degrees of freedom to get the mean sum of squares between the means. Finally, I have what I need to calculate the F statistic. The mean sum of squares between is equal to 8.6. The mean sum of squares within the groups is equal to 2.1. The value of F statistic is determined to be 4.09. The larger the value of the F statistic, the less likely it is that the means of the populations of the three groups are equal. So now it's up to us to determine whether this value of F is large enough to reject the null hypothesis that the means of the three populations these groups are drawn from are equal. This distribution represents the probability of getting a value of F if the means of each of the populations are all the same. The red region represents the probability that we'll be wrong if we reject the null hypothesis. For the purposes of this analysis, our tolerance for error is only 5%. So we want an F value that's large enough that the red region will be less than 5%. F distribution is dependent on the number of samples and the number of values within each of those groups. So each one is going to have its own distribution. This table summarizes the value of F that we need to exceed for a probability of error of 5% or less. The columns represent the number of degrees of freedom between the means. In this case, that's 2 degrees of freedom. The rows represent the number of degrees of freedom within the groups. In this case, that's 12. The intersection represents the critical value of F that we need to exceed to assure us that we have less than 5% chance of being wrong if we reject the null hypothesis. Comparing our calculated value of F to the critical value of F, we see that 4.09 exceeds our critical value of 3.89. We reject the null hypothesis and accept the alternative hypothesis.